You have to see the animating insanity from one of my favorite free artwork GIFs. So topic today is automate yourself out of a job. I'm Adam Ivy. I'm the only one, so if you want to find me on LinkedIn or something, that's pretty easy to find me there. You can go ahead and reach out. I'm also on Twitter as Antic. I'm a little eclectic, so I don't always talk about software, but you can also find me there. And these slides, of course, this video is being recorded, but the slides themselves are on this bit.ly link, automate_yourself. There's lots of links embedded within this talk to other articles or other things that you might find interesting. So here we go. So first off, I'm a principal software engineer. I've been doing software development for about 18 years. And I've done a little bit of everything from development, prototyping, security, operations, kind of the whole full stack. For the last couple of years, I've been doing machine learning off and on, along with lots of other random projects. I pretty much do everything that's prototype to production. And when I got into the industry, it was really with this idea that I wanted to understand computers because I don't want them to control me. I want to be able to control them. I don't want to be, at the whimsy of online banking and social networks stealing identity and all that kind of stuff. So I've always looked at it from a security perspective. And I've been interested in automation for the same reason, right? Having some control over your life in the digital world is pretty important to me. So you might be starting off with this idea of like, wait, automate yourself out of a job. That sounds insane. Why would you want to automate yourself out of a job? And the core of the argument that I want to make here is that if you're automating yourself out of a job, you're going to then have the skills to do the job that replaces the stuff that you're doing today that is then automated. So, just by working on automation and removing tedium from your life, you're actually going to free yourself up to do the things that are much more important, the things that really matter. And we'll go and talk a bit more about that. I'm sure you all know jobs are, transitioning quite heavily, and because of the recent pandemic, just as of last Friday, I don't know what the report is today, but 36.5 million unemployment claims have been put in the US, which is about 23% of the workforce, right? It's a huge rate of unemployment. That's kind of unprecedented. But with that, all the people that are working from home that are still continuing to work, a lot of those folks are working in software. They're building automation. They're working on robots. They're essentially working on the technology that's transforming the jobs that are now not happening. So a lot of the jobs that come back into the workforce, once all of this stuff comes back and slowly recovers, those jobs are going to be changed. As they've been changing, right, slowly over the decades already, they're going to be changing a little bit faster. So it brings up another question, which is, why should we go ahead and embrace this hidden agenda of the Davos elite, right? If you want to get conspiratorial, there's a link to a New York Times article on this for those of you who haven't heard of it. Davos, Switzerland has the World Economic Forum that meets every year. So it's, essentially the highest wealthy elite get together and kind of talk about, what their plans are for the global economy. It's not a secret Illuminati thing. It's a very public event. But, reporters that reported on the last one were kind of shocked to see that there's two conversations going, right? One that is, we want to automate cautiously because we know it's going to disrupt people. And the second conversation is, we have to automate as soon as possible and get rid of humans as fast as possible because our competitors are doing it. And, that's how we're going to survive. So I want to make an argument that this is not as conspiratorial and, dire and doom and gloom as it sounds. Even though that may be, the balanced conversation, there's a lot more to it that is going to come and develop. So if we take a step back and look at agriculture jobs, in the early 1900s, about 60% of the US workforce worked in agriculture. And at that time, economists were looking forward to like the 1970s. They were predicting out in the future. And they said, hey, with all this industrial revolution, we're going to lose all these agriculture jobs. Humans are just not going to do them anymore. And people are probably going to only work 15 hours a week. and it's going to be a totally changed world where people are just not going to work as much, or maybe not even at all. And if you look forward to last year at the reporting, less than 5% of American workers actually worked in agriculture, right? So we foresaw this massive change in the ecosystem, but people in the early 1900s, they just had no idea what kinds of jobs would exist that would replace agriculture. The technology wasn't there. There was no clue. So this theory that we would have a 55% floating unemployment rate during normal times didn't really happen, right? Instead, we have tens or hundreds of thousands of different jobs and roles that they just couldn't imagine, that just didn't exist then, that were enabled by all kinds of levels of technology upgrade and automation. So, I would argue that science fiction has not really yet imagined the jobs that'll exist in 50 years. We look at science fiction and get a lot of ideas for how we're going to develop new technologies. And I would even say that probably not even 25 years, right? If science fiction were accurately predicting that stuff, and you really had a solid grasp of what jobs were going to exist in the next 10 or 20 years, you would have created AWS before AWS happened, right? You could have created Amazon or any of these big technology changes that we've had in our lives, right? Facebook, Twitter, all these things. You could create it before somebody else and then become a billionaire, right? It's a hard problem to actually figure out what the next phase is, but it's pretty easy to look at what the tedious tasks are we have now and just automate those and keep leveling it up. So I also want to tell you a story about VisiCalc. This was the first spreadsheet piece of software in the computer world. And before VisiCalc, companies would have rooms full of accounting clerks and bookkeepers, and they would be manually by hand doing all of this, double entry bookkeeping, tallying numbers, or recalculating the math, a very error-prone process that required lots of humans to double check the work and cross-check on multiple pieces of paper. And if you wanted to project something, like what happens if we buy that company, or what happens if our profits are down 5% over last year, you have to have these humans go and recalculate all of these numbers. And it was very difficult to do and very expensive. So VisiCalc came out, and since 1980, this birth of electronic spreadsheets, 400,000 bookkeeping and accounting clerk jobs have disappeared, right? Companies don't have to have those rooms full of accounting clerks anymore doing this manual work. Now, those jobs didn't just totally vanish, they actually transformed. And so as a result, 600,000 accounting jobs were actually created because of this technology, because it lowered the bar to entry, and it gave companies and people magical powers that they didn't have before, right? You could do so much more with fewer people. And so some of those bookkeeping, accounting clerk jobs did actually dissolve, and the people didn't move and pivot with the times, and either retired or did something else because they didn't stick with it. And new people entered the space into the accounting world that didn't have the experience and skills to do what they used to do, which was tedious and terrible, but can now learn how to do things with spreadsheets that that were unimaginable before. So I'm a spreadsheet junkie myself. I have massive, insane spreadsheets in Google Sheets that color code dynamically, and they've got functions to tally and ripple through here, and they're fed from APIs. And I've got automation at home where I've got a Node.js service that goes and scrapes data from various APIs, and then it goes and plops this information in a place where a spreadsheet can dynamically load it. And these are things that I wouldn't even imagine that I could do this 10 years ago, because the APIs weren't there, the technology wasn't there, the supporting libraries in online spreadsheet management just weren't there. And so the idea just didn't really happen. You'd have to pay a company 10 years ago, you'd have to pay a company lots and lots of money as an annual fee to run a service like this. So it's good to keep in mind that engineers are privileged, right? Our job is actually to build automation, right? No matter what you're doing, even if you're building something like a login page, you're building software tools that make something vastly easier through programming. If you work in a factory, if you work in a job that it's not part of your job to actually contribute to the automation of getting yourself out of a job, then you're in danger. So it's, look at it, if you are empowered with the ability and rewarded for creating automation, you're in the right place, right? You're going to keep surviving in the industry. It's also good to keep in mind that no matter how much you like a company or the products they make, companies don't love you. There's a great article here by a former NPM developer who, essentially realized that corporations, Delaware LLCs are not loving entities. And so you want to keep building your skills. You want to keep stretching into the adjacent possible. I found great utility in my career in just looking around, right? If you get a job as a software engineer and, you're building a login page, for example, something really, seemingly simple, there's going to be all kinds of things around you that aren't being done optimally, right? Maybe there's the build process isn't quite there, the testing process. There's tooling that needs to be put in to help developers succeed better, to get people onboarded better. And if you're able to kind of dabble in these things, look at what needs to be done, and add a little bit of your skills, evolving toward solving those problems, then you're going to have lots of things to do in companies. There's really no end to work. I am not doing any of the same things that I started out doing in my career. All of the things that I had to do way in the old days of creating web servers by hand from scratch, to scaling them manually, to running security patches manually, to even writing lots and lots of code that now today is just one-liner library inclusions. All those things, nobody's doing those, not just because my skills have gone up, but because that's just not what people do anymore, because it's all automated now. So always be ready to change role and kind of pivot what you're learning to do. This software engineering is really all about just learning new things every day. And as we do that, there is a shifting responsibility, and you'll see this, through your career. You'll come up with, the first question is, can we do this thing? Is it possible to do this thing? And then very quickly, as all the automation is in place and all the plug-and-play libraries are in place, the question changes into, should we do this? Is this actually the right solution? Is this the right thing to do? And it's a good thing, because it's putting us as humans into more of a creative world, right? Into more of a philosophical world where we can say, is this the thing that we want to do, rather than, is it even possible? It's really common to see this kind of stuff, even in software, where you'll be presented with something that seems like the thing that you have to do. And I've been rewarded in the industry from going back and saying to people, to product owners and stakeholders, okay, we think we want to do this, but looking at it critically, looking at it from a user experience perspective or a company liability perspective, this is not really the answer. There's some other thing that we could do, or we don't need to create this huge robust system when we can just stand this function up in a Lambda and it does the things that we want. So there's, thinking about those things at a more critical level is really important. And likewise, as an example from the automated car world, you got to be aware of false problems and false solutions. So some of you have probably heard of the trolley problem. It's a philosophical experiment from way back in the day, and it's been brought back by MIT doing a research study on, should automated cars kill the baby or the grandma, and it kind of did a little crowdsourced evaluation of that. And the danger of looking at philosophical problems like that as just software engineering problems simply is that it's a choice of bad options. And in building software, you don't have to actually integrate and design bad options into the system, right? Instead, you can focus on what is the real problem that we're trying to solve. And driving safely is not actually that hard, right? You slow down and stop. 5 nines of driving accidents happen because cars just aren't stopping in time from running into something. So the real problem, the hard problem in autonomous driving is actually finding a legal parking space. It's hard for humans, it's hard for cars, and mostly it's because the rules are hard to codify. There are so many different rules and so many exceptions to finding a legal parking space. Whereas finding, a safe way to slow down and stop, there's really just one mechanism, right? Decelerate, stop. So real engineering problems in the space are things like, Why didn't the brakes work? Why was the car driving too fast? Why didn't it see the problem earlier? And these are really easy, small things that we can look at and tune and continue to fix. And we probably will never get to a point where we actually need to build a morality engine to make bad decisions when it comes to automated driving. That's so far in the future, it's not an engineering problem we're solving now. So I can't emphasize enough, if you're engineering solutions to problems that we don't have yet, you're going to end up having hazards that never existed before, right? Once you have a morality engine in a car, now you have a hacker being able to manipulate a car into murdering somebody because the car thinks it's a moral judgment choice. So that just opens up a huge can of worms. I gave a machine learning class a while back, designed this with a coworker of mine, and it's up on GitHub. You guys can all take a look at it, and it's a self-driven thing if you want to go through about 3 hours from start zero to playing with machine learning. And the question came up a couple times of, how worried should we be about, this machine learning stuff destroying our jobs and then ultimately destroying humans, right? Essentially just making humans obsolete. And we are automating some really interesting things that are, even on the creative end, right? This is Samsung AI Labs doing a one-shot learning where you take a photo and just turn it into a 3D model, essentially, where they can animate the face and make it talk. And we're also automating robots, right? Things like you've seen Boston Dynamics Spot opening doors, which could, relate to the Black Mirror episode with the murder dogs. So there's a lot of media that kind of will convince us or make us a little bit wary of robots being these potential destroyers of humans. And then, you get stuff like this where, robot fighting back when it's being, beat tested. And then, of course, it's revealed that it's actually very, very difficult to make a robot that is not only capable of fighting back, but even wants to fight back. It's much easier just to throw some CG on a human dummy that's going through the actions. And really, this is actually kind of the state of the art of robots today.
Now, everything doesn't go exactly the way it's supposed to.
Right. We're very, very far from, murder bots. So that's a good thing to keep in mind. Really, in today's terms, most machine learning and most AI, which is really machine learning typically, is really just stupid math, right? It's is this number closer to 1 or closer to 0? And maybe we're measuring millions of those numbers, and it's a lot of brute force work that we want the computers to do. And most of the time, the humans don't even really know, what that data represents. And sometimes it's right, and sometimes it's not. We've got some examples of how that goes wrong, but it's really not that complicated. And today even you can plug and play stuff. So I was just chatting with a friend who wanted to make a coronavirus, don't touch your face app. And, looked around and, he was going to go, hardcore into, back-end systems and building a robust machine learning algorithm, which may still be a good idea because this stuff isn't perfect. But, quickly looked and like somebody had just mashed together Face API JS and Handtrack JS and created this no-touch challenge website. And it was literally just glue, right? Plug this library into that library. So these things are available today in ways that they weren't before. And you can do some pretty incredible things. Really good to keep in mind that in coding and software, laziness really is a virtue. You want the computers to do the work and not do it yourself. But you want to have smart laziness, right? You don't want to do more work now, and you also don't want to do more work later because you failed to set yourself up for success that way. So, be smart about laziness, modularize function, turn things into functions that you can reuse into libraries. Big part of this is, keep your code dry, don't repeat yourself. You'll see this all over the place in code. Great example is, all code libraries are basically automation. If we look at before jQuery, in the old days of JavaScript selection, right? Let's say you needed some HTML and you wanted to select the foo ID, you'd say document get element by ID foo. And then if you wanted to get bar, you'd say, okay, document get element by ID bar. And that's repetitious, right? This is a lot of redundancy. So you could capture that function, get element by ID, and put it in a variable, say dollar arbitrarily. And now you could say foo is dollar with, foo is a string passed as a parameter, and same thing with bar. And now you've got like a nice convenient way to do that without having to type document.getElementById every time, or even just look at it, right, as a lot of extra code in your code base. And so you can imagine that John Resig, when he put together the jQuery library the first time, it probably looked something like this, right? That was like, hey, there's not only getElementById, but there's class name and tag name. And we can kind of simplify and add one interface for, fetching whatever DOM element you want by a CSS selector. And of course, it got a lot more complicated because there's all kinds of rules for CSS selection. And then at some point later on in the jQuery days, I don't remember which version, the browser standards came out and said, well, actually, this is really useful. We should implement a document.querySelectorAll that just takes a CSS selector. And now, jQuery has embedded within it, if this is available, just use that. Otherwise, fall back on all this big logic for how to parse, strings into CSS. And there's a website called you might not need jQuery.com that goes over a lot of examples of how jQuery is developed as a system, and this is very common in the JavaScript world. JavaScript has, in the early days, it was a very different language than it is today, and the changes that have come out to the underlying ECMAScript have really been driven by the community building tools like jQuery and Lodash and all of these utility helpers, and kind of thinking about, well, what wouldn't it be nice if the language had this? A lot of the browser standards are really just adapting around these tools that developers are making and sharing with the ecosystem, saying it'd be great if this were a standard. So if you're automating the right things, if you're automating things that are problems for everybody, then they become standards for everybody, and that's really fun. So if you look at something, and I encourage you early in your software career, that if you're hitting your head against something, anything, it can probably be made simpler, and it can probably be made simpler with a tool or a library or some kind of, even just good documentation. And by contributing to that ecosystem to make things easier for the next person, you're going to be setting yourself up to create not only the automation and the software, but kind of become a person in the industry who's known for doing that. That's going to get you more jobs and get you further along in your career. There's a lot of ways you can start doing this kind of stuff for yourself. There's a lot of people out there who have .files projects. And .files is really this idea that all of your system configuration, all of the tools on your computer, the software, your preferences, all that stuff, those are all stored in configuration files. And so, I've changed my laptop, I don't know, a dozen times in the last 10 years. And every time I do it, in the first few days of doing that, first few times, it was a pain, right? You have to copy your files and back up stuff and reinstall software and set up your settings the way you want. And then people started saying, hey, it's great if you just back all this stuff up and then make a script to automatically extract and implement all of your settings and all of your software. And then it's easy. So the last few times that I've swapped out my laptop, it's been like, great, that's not a big deal. I'll just, run my script, and, in less than an hour, I have a brand new laptop that works and looks and has everything on it that my old laptop had. So it's a fun way that you can add some automation to yourself. It's just a backup strategy. You don't have to use mine, but I've got mine online. There's a .files directory for other people who have done similar things. There's a lot of different ways you can slice it, but that's definitely worth looking at. It's also not just for code. Tedious tasks are seriously all over the place. We've got people building, IoT projects to water their plants, or, you've got automated coffee makers, things in the morning, right? Automation is really becoming a part of our lives everywhere. I do a lot of drawing, and one of the things that artists do is, practice drawing rotating cubes, right? Just as a mental exercise. And I was doing this one day, and I thought, am I getting these rotations right? And am I getting all the options? And I was like randomly drawing rotations. And I thought, you know what? I should just code this up in JavaScript and CSS, because I can make 3D boxes with CSS and, with JavaScript, essentially just iterate on all of their rotations. So there's some code there on GitHub for that. But when I made that, I thought, this is really useful in a totally non-software context. Just the ability to write code to automate and iterate on something. And also, I want to argue it's not just about saving time. You might spend an hour writing some automation for something that is only going to save you half an hour of time. And I would argue that you still want to spend the time doing the automation, because it's going to give you, first off, the experience of automating things, just going to level you up in that regard. It's probably going to give you some more libraries or some more tricks. So the next time you go to automate something, you're going to be a little bit faster. And it's great practice. So my wife is a teacher, of course, at CodeFellows. She used to be a TA, and she was talking to me about how tedious it was to grade assignments, right? She'd have to go to the GitHub repo for the student, check that there's a README, clone the repo, install the dependencies, run the app, make sure it works, check for a few things in the code. And, I'm looking at this list thinking, wow, that is really, tedious, big, strong buzzword there for automatable. Let's look at automating that. You should keep in mind that any language, anything you do on a computer can be automated. Everything from clicking mouse buttons to downloading a Git repo, all of the things you do on your computer can be automated. We write automated tests, to mimic the behaviors of humans. And testing libraries can be a great way of just automating away some things that you don't want to have to do again and again. But writing your own test from scratch can also be not that daunting of a task if you get comfortable with shell scripting. So, when you do something like a git clone or, any git action, that's really interacting with a programming environment, which is most likely a bash shell. And so if you do that, you've got a few Unix tools that are at your disposal. And, if I could recommend, learning or at least just getting basic grasps of 4 Unix commands, cat, grep, awk, and sed, these will do so much work for you that you can do things where normally you might think, oh, I need to actually set up a whole programming language for this, right? Python or JavaScript or Java or whatever, might have to compile something, where you could actually just do what you need with command line tools. So here's an example where, let's say we've got a text file called weather.txt, and it has this chunk of data. Maybe we download this periodically from a weather service, and this is just how the file ends up being. And let's say we want to extract the 64-degree Fahrenheit chunk out of that data. Well, we don't need to convert this to JSON and parse it and turn these into key value pairs or anything. We can actually use these tools. So cat will take the content of the file and echo that out into standard output. The pipe symbol here will take standard output and feed it into the next command. So basically we take this whole content and we throw it into grep, and then grep looks for the line that contains the match. So grep finds this line and then it pipes it to awk. And then awk has this beautiful command, and awk is like a whole programming language in itself. It's insane. But the one thing that you will use again and again if you use this kind of stuff is just this print function, which it'll split the word into space delimited sections. So print 1 would be this chunk and print 2 is this chunk. So it captures that chunk and then pipes it into sed, and sed can do regular expression replaces. Regular expressions also I can't recommend highly enough to really get comfortable with, because it will save you so much time once you understand basic regular expressions. So what this does, it says find the comma, and then any character, 1 or more times after that, replace those with nothing. And so what comes out of it at the end is just this chunk that we looked for. So these tools are totally invaluable. Just kind of start to think about that, as you're interacting with the command line, that you are in a programming environment and you have tools that will allow you to shuttle data, to manipulate data, to do search and replace on that data. And that's going to enable you to do all kinds of cool things. So if we look at this from the problem at hand of how do we automate some grading of projects, the script might look like this. Maybe we create a test.shell script, right? Common file ending for a bash shell script. and we'll say that we're going to use the bash interpreter in order to interpret this code. And we'll put a git clone, so same thing that you would put right into the command line. We're going to clone a GitHub repo, and we'll take some arguments into our script, a username and a code repo name. So we'll plug those in as 1 and 2 here, and then we'll change directory into the repo name folder, and then we'll see if there's a file called readme, then we're good, and otherwise we'll throw this, echo this error. And then we'll install the dependencies, sending the output to dev null because we don't actually want to poison the UI and the screen. And then we run npm test, and if npm test throws an error code when it fails, then, or if it doesn't throw an error code, then we're good, we'll test pass, and otherwise, test failed. And so if you run that, then that could be a really rudimentary way to test, download, install, and test a node project from a GitHub repo. And then you could say, all right, now I could take this and I could put a meta wrapper around it with like a list of usernames and repos and run it until it's done. Now, though that sounds easy, you got to keep in mind that automation really can't be trusted. There probably are edge cases. There's always edge cases, right? Somebody might have created a README that has a capital MD as part of it, right? So this script is going to fail, even though maybe that's a success. So you've got to keep in mind that if there are edge cases that you want to support, you have to codify those. Those have to be part of your automation, or your automation is not going to be robust enough, and you're going to end up failing things that shouldn't be failures. Good to keep in mind with automation, with especially machine learning, the simplest solution generally wins. If machine learning can cheat, it will. If you don't define your parameters and your desires fully enough, you're going to get crazy things that you don't expect. So one fun example that I like from this is some machine learning team was trying to get a system to evolve animals that could run fast. And what ended up happening is the system created some absurdly tall creatures that could fall over very quickly. And it satisfied the need to create creatures that could move quickly. But of course, it didn't really fit the parameters that they were trying to create. But it was a cheat, and it worked. You also get really immediate catastrophic results sometimes. So we have to be aware that if we ask AI to cure cancer, just blatantly like that, this is kind of the monkey paw curse style wish fulfillment, right? It'll say, great, if I kill all people, all humans, destroy all animals, then there's no more cancer. That's the simplest way to do it. And it's probably through a brute force evaluation, it would come across that before anything else that works. So you have to define your parameters really, really well. It's also, you might be thinking, hey, once I go to a company like Microsoft or Google or Amazon or something, they know what they're doing. They're gonna have all this stuff nailed out, and it'll be great, and I'll just do what they do. But it turns out that actually even these big companies that have really smart people, and they really do have really smart people that work there, they make huge catastrophic mistakes when it comes to automation. So Microsoft had this issue where they made a chatbot. They, internally in their dev team, they talk to it and it sounds cool, and then they throw it on Twitter, and of course you expose it to the internet. It's a very different environment than a bunch of software engineers. And so it became a Hitler praising racist in 12 hours. Then there's automated products on Amazon, which of course, are not trying to evaluate. There's no human involved in these. And you get products like Keep Calm and Rape a lot, total epic fail. And then Google got in huge trouble because they had a photo tagging algorithm, which if you don't put enough training data in your algorithms, you're going to get really, really bad outcomes. And of course, they did not have enough training data specifically around people, which is a really big problem. So final takeaways. I know there's a lot there, a lot to think about, but basically don't fear automation. It's really part of your job as a software engineer. And it's kind of fun if you think about it as how can I remove the tedium today? If you get comfortable with the command line, you're really gonna be in a better world. Avoid tedium kind of at all costs, right? If something, something takes you 5 minutes, even if it takes 15 minutes to create a workaround for that that's automated, it really is worth it so that you don't have to live with that tedium, right? Because maybe it's 5 minutes, but it's 5 minutes every day for the rest of your life. Sometimes it really adds up. I'm a big fan of using emoji in logging. I think that's super helpful because as you're iterating automation, you want to be quickly able to see as a human what is going on in the system. And I've found great results with that. It's as simple as that sounds, just putting images in log files. It's still ASCII. It's totally valid. You can log to any cloud logging provider with ASCII or with emoji, and it totally works. And really focus on iterating, right? When you're building automation, try to start your problem, stop the problem, run it through again and again. That's where you're going to find all the bugs. That's where you're going to find edge cases, right? If you just keep throwing things at the program that you're trying to build, try to build that pattern, right? Of just continuously starting it until it fails. And then finally, just don't trust it, right? If you're trying to build automation, if you're trying to build something that's doing something again and again, have another thing that's watching it that makes sure it doesn't, throw some weird error, or that it finds something that looks really weird that isn't right. That's the gist. Like I said, you can find the slides here on bit.ly. Automate yourself, automate_yourself. I'm Antic on Twitter, Adamantic on GitHub, Adam Ivy on LinkedIn. Does anybody have any questions, comments, gripes?
Adam, great job. How you doing? Tom Scott.
Good.
Listen, you talked a little bit early on about your ability to create automation for existing workflows within the work you're doing. One of the things I was curious about is the need, or your thoughts around the need for an advocate of that work, because often I find the work coders are doing without an advocate on the executive side to help sponsor their work, there's a loss of translation between the work they're doing and how it aligns with business function. I was wondering if you have any thoughts around that.
Yeah, quite a lot, actually. I mean, that was a role that I had put forth, proposed in my last group, was a developer advocate role, specifically for that, right? As a way of saying, what problems could we solve within the developer ecosystem that make it easier to onboard and to help people get running with other teams, right? I mean, I work for a big company, and there's lots of different teams. There's lots of stakeholders that are wanting different things from different teams. And it's hugely powerful if you can get developers to be able to work with other development teams and easily run each other's software and work with each other's software. And so, yeah, having the right tooling and I think it's an easy selling point, to a point, right? Everybody understands this, right? That if you enable people to do more work better together, that's going to make everybody stronger and everything. But there's a trick of aligning, right? Financially and in priorities.
And finding the advocate, that's the key too. You have to find the person with the right attitude, mindset around the work you're doing. I think that's an important part of the work, because without it, that work, as you just said, kind of this, the full advantage hasn't been taken care of. What's your recommendation for developers to seek out that kind of person?
You mean to seek out the person on the business side, or to seek out more of the advocate?
Well, it could be one and the same, but yeah, say on the business side, because that's where the disconnect is between the business and the code. And I'd like to understand if there's a path you could recommend. Is it through like chatting? Is it networking? Is it doing things like you're doing? Go ahead.
So in my career, I do a lot of these presentations. And I've found that's been really helpful, is saying, hey, we have this idea, we want to do this thing with this group or whatever. Put together a presentation and pitch that. I mean, it could be a coffee meeting, but if you put together stuff visually, I find that helps a lot, especially to folks that are not writing software, right? They're thinking about this stuff in a different way. And if you can say, with icons and images, this is how it's going to improve the system. That's a lot easier, I think, to sell and get people on board and get advocates.
Great, thank you.
Yeah.
So, kind of along the same stream of questioning, as far as like if you think that there's a pain point that you would like to solve with an app or something of that nature, is it best to like flush things out by yourself even if you don't have a lot of experience? Like, let's say I want to help people plan gardens, but I've never planned a garden before. Do I go to people who are working in that industry and see what they want first, or is that something to go later on and then talk to them and be
Yeah.
like,
So, I mean, this is maybe a little bit outside, but yeah, as far as like startup companies and user acceptance testing and that kind of stuff, or market tests, that's kind of how the startup world is realizing that doing product market fit tests as soon as possible is a great idea. Getting actual people that are going to do what it is that you want to do, right? That's why when I focus on automation, a lot of things I automate are just things I want to automate for myself, right? I'm the customer. You want to have a customer for your automation that you can kind of test it again and again and again. Because yeah, if you're just working in a black box, you may be missing a lot of the nuances of what people are actually looking for. That
Yeah.
thank you.
And one last question: what's the difference between self-healing and automation? To me, they're kind of the same, but I'd be curious what your thought is on that.
Well, automation doesn't necessarily mean healing, right? Automation might just be doing tedious work. Self-healing is specifically a part of automation around incident recovery, right? Recovering from failure of the automated system, right? So you may have an automated system that's just running, and then what happens if it stumbles? You've got another automation checkpoint that does something to correct the system, right? If a piece of software crashes, for example, then you may have some recovery logic. Does that answer the question?
Yeah, yeah, it does. I mean, I kind of saw it as something different, but yet it is automation in essence. Is it always just for recovery, or is self-healing also optimization tool?
Yeah, I don't know if that, maybe my opinion on this is more semantics and doesn't really impact a lot, but I think, yeah, I mean, I would think that strictly it would mean, that self recovery is a automated tool that would be on top of some automated system that you're running.
Yeah, it's all part of automation. All right, thanks.
Yeah.
So, Mason, I absolutely love everything you had to say. Just the idea of why you should automate yourself out of a job, like that speaks to my soul. It's one of the main reasons that software development called to me. And growing up, one of the things that just kind of gave me this sense of existential dread was the idea of doing the same thing 8 hours a day, repeatedly, over and over, for all of the best years of my life, when I have so many things that interest me. Like, I've never been, I'm 30 years old, and I've only just now found something that I'm passionate enough about that also allows me to be able to kind of explore all my different ideas. And I had a question. Is that, would you say that we're kind of moving away from the idea that the specialist is the be all end all, and more into like a modern renaissance of people that can do lots of things and dabble in lots of things are going to be much more valued?
Yeah, I mean, I'm coming from a biased place where my whole career I've been in the jack of all trades, area. Trying to work full stack, trying to touch lots of different things to understand the holistic system. But I've found that that's been hugely valuable, right? Like, I'll talk to somebody who just writes Java code, Java APIs, and they don't know how to create a UI, right, or to do the database layer. And if you know how to do all of these things, a little bit, I think that's more valuable than being the best, Java programmer in the world, right? But that certainly is valuable, but you can do more things, right? You have more options, and it's all about options for me.
Awesome. Thank you so much. I appreciate it.
Are there any resources that you would recommend for kind of getting started on the dot configuration file stuff?
Yeah, so I mean, you can take a look on this deck, or if you just search for dot files, there's the dot files project. I got to put a link. Oh yeah, here. There's the dot files directory. There's lots of people have done this. So yeah, I think the thing to do is take a look at what some other people are doing. Mine of course is Mac centric, since I have a Mac and that's how I build my stuff, and I don't want to build like a universal dot file manager. But get an idea for what's out there, what kind of tools you want. You could start one from scratch, but if you start with somebody else's scaffolding, that might be a good way just to kind of play around and start investigating and see what options are there. Yeah, or just pick around. I mean, when I was building mine, I went through a few other people's dot files and I said, oh, I like that piece. I like that piece. I'm going to take those scripts and bundle those into mine.
Okay, yeah, thank you. Appreciate that.
Yeah.
Nice presentation, Adam.
Thank you. Well, we are at the hour, so if anybody has anything else, feel free to hit me up on, Twitter, LinkedIn, anywhere. I'm all over the internet if anybody wants to chat. Otherwise, yeah.
Got a question in the chat.
Oh yeah, sure. Oh, I missed the chats. Where is that? Oh, look at that. Let me see. Okay, let me see here. Computer upgrades. If you're a Mac user, Time Machine makes upgrading. Yep. Yeah, Time Machine is definitely a good thing to use. A big board. Yeah. And yeah. And yeah. So let's see. What advice would you give to a new developer right after 4-year CS degree or after CodeFellows, who's on the first year of a job to continue to grow and stay marketable? So I think, so if you're on a job, when I got out of school and I went and got my first tech job, I learned way more in the tech job. And a lot of what I was learning was, as I was hired for a local company called Sublime Media. This is back when there was like 5 people that worked for the company. Now it's like a 250-person company. But at that time, I was doing, Illustrator graphics and ActionScript and JavaScript for these e-learning things from Microsoft. That was our core client. And there were lots of problems that we had just in trying to do this as a team, things like file management. So I set up Subversion as the repository system. This is way before Git. We're setting up processes for how to work on different pieces of code together, finding shared library patterns. There was a lot of things that, any company has a deficit in some case in the software engineering chunk of their group. Where things just aren't optimal. And if you can find those places and say, oh, maybe I can help out there and kind of stretch into that, help out the QA folks, help out the project management folks, and planning and estimating and writing QA software and developing tools. That's gonna broaden your skill set so much, and it's gonna make you really valuable to the team. So that's gonna help you, in just how you interact with people. And then if you're interested in, in staying marketable and keeping kind of a finger up on the pulse of the industry, recruiters are, good and bad. I wouldn't take every job through a recruiter because they do take fees, they take cuts, but it's really good to network with recruiters and other people in the industry. Hit people up on LinkedIn, respond to recruiters, even if you're not looking, say, hey, great, thanks for reaching out. Let's, stay in touch. I've been doing that my whole career. And I have lots of great contacts that way. It's a really great way just to keep building. And yeah, I mean, as far as being marketable, when I've hired people, the core thing that I've looked for, don't care about where they went to school, don't care about, most of the details of the resume just get lost. What the first thing that I've always been looking for is, where's your GitHub account? Where's your online portfolio, right? With just samples of what you're interested in. And that's more what I'm interested in than what you've done, is what you want to be doing. And, can you show and demonstrate, even if it's like, hey, I have some bad code and I can talk about, in here, this is old code that I did for class. what would I do differently now that I know all the stuff that I know since I wrote that code? That's a really good conversational point. So I would tend to use that in evaluating folks for bringing them in for interviews more than like where they worked. Does that answer the question? Okay, cool. Awesome. All right. Well, I think we'll wrap that up. So yeah, like I said, feel free to reach out to me if anybody has any other questions.
Thank you, Adam.
All right.
Thank you, Adam.
Thank you.
Thank you.
Thank you for the time.
Thank you.